Today we get to do elimination. We are continuing solving a system of equations. So here's the key concept. It tells you exactly keep adding like things down. So a 3y and a negative 5y, that is going to be a negative 2y. And last but not least, a negative 3 and a 5 is going to be a positive 2. Okay, so I've eliminated a variable. From there, all I have to do is solve for y. That should be pretty easy, just a little bit of division here. And y equals negative 1. A lot of people like elimination because it is pretty quick. There is a catch here, though. If you remember when we did it by graphing, right? Where did the two lines intersect? We did it by substitution. Our answer wasn't just a variable, y equals this or x equals that. It was a point. So we do need to take this, come back up here, and plug it in. It doesn't matter which one you plug it into. As long as you do your math correctly, you should get the same answer no matter what. I think I'm going to do the bottom one. I like 5s better than I like 3s. I don't know. So 4x minus 5, plug in that negative 1 for y, equals 5. Whoop, I don't know what that was. There we go. Let's see. 4x, a negative times a negative makes a positive 5, and it equals 5. So if I subtract 5 from both sides, actually, I have 4x equals 0. And if I want to get x by itself, I do need to divide by 4, which is just anything. 0 divided by anything is x equals 0. So my answer as a point is going to be x comma y. So my final answer is 0, negative 1. Now, of course, it wouldn't be fun if we didn't make it more difficult, right? Let's check out number 3. Solve the system of equations. So on this one, I'm going to add them together, and I get, hang on. I'm adding them together. Don't automatically cancel those b's because, look, 8 plus 8 is actually 16b. This didn't help me at all. I added them together, and none of my variables canceled. This was useless. Okay. What if we try subtraction instead? Now here's the thing. When you are adding all 3 items, right? In this case, you are subtracting. Once again, you need to subtract all 3 things. It's very, very easy to forget to subtract. So here's my suggestion of what you should do. Turn all of these into adding the opposites. So change the sign on all 3 items on the bottom one only. That's going to help me remember to subtract all of them. Because now I have 8 minus 8, or 8 plus a negative 8. That cancels. 3 plus a negative 7 is the same thing as 3 minus 7 is negative 4c. And 11 plus a negative 7, which is the same thing as 11 minus 7, is a positive 4. See, now I have just one variable left to solve for, which is much easier. And of course, I know I need to plug it back in. Again, it doesn't matter which one. I think I'll go to the top one. 8b plus 3 times negative 1. Notice I plugged in c. 8b, that's minus 3. So now if I add 3 to both sides, now I can divide. And it looks like I have a fraction that simplifies to be 7/4. Oh, hold on a second. My points are supposed to be in xy. I have a C and a B. So how do I know what to put first? As a general rule, put them in alphabetical order. So in this case, it should be BC, which means my answer is 7/4, comma, -1. Okay? All right, let's make it super crazy now. Look at 1A here. Here's the issue with this. If you're looking at it, it's not going to matter if I add or subtract. Nothing is going to cancel, right? Because none of my variables are the same. You can make it the same, though, using a little bit of multiplication. And 1A is not too bad because I can see that 3 is pretty close to 6. Like, it's a nice multiplication problem there to get them to be the same. Whereas like 2 and 7, there's no way I could multiply the 2 to become a 7. Here's what I'm going to do. I'm going to take the bottom function and I'm going to multiply the whole thing by 2 so that I'm essentially distributing, right? So now I have 6x minus 14y equals -38. Oh, there we go. Okay, what I was asking myself when I did that was, how can I make this 3 look like this 6? And the answer was multiplying it by 2. Okay, kind of get rid of some of that there. So then what I'm going to do is literally just drop that top equation down. 6x minus 2y equals 10. Now I have where the x's are the same, I can add or subtract them. And it looks like I'm going to need to actually subtract them. If I had wanted to, I could have multiplied by -2 because that would have made that top one a -6. But it doesn't matter. Just change all the signs. I noticed -2 is already negative, so I turn it into a positive. Sweet. It wouldn't have mattered which one we make negative. It's all going to work out the same in the end. So now my 6's cancel. That looks like a -12y. And what? A -48. Is that what you get? If we had made the top one negatives, like if we multiplied by -2 and so the top one, all those signs were flipped, you would have ended up with a positive 12y equaling a positive 48. Positive divided by positive makes a positive 4. Negative divided by negative makes a positive 4. Same answer either way. Okay, then you're going to come back up, plug back in. You guys know how to do that, so I'm going to move on so that you can see another weird example. Let's try maybe 2a. Here's the problem with 2a. Again, I'm asking myself, how can I easily multiply one equation to turn it into the other? I cannot easily multiply the 2 into a 5. If I want to strictly multiply by integers, that's not going to work. I cannot easily multiply the 3 to become a 5 either. So this time, I'm actually going to be multiplying